Understanding the ExpSineSquared kernel in scikit-learn. The ExpSineSquared kernel, also known as the periodic kernel, is a powerful tool for modeling data with periodic patterns in Gaussian process GP regression using scikit-learn. It is particularly useful for capturing cyclical phenomena like seasonal trends, oscillations, or periodic signals. Key features of the ExpSineSquared kernel. 1. Periodicity. It explicitly incorporates periodicity into the kernel function, allowing it to model repeating patterns in the data. This is achieved by introducing the sine function within the kernel's formula. 2. Length scale. It has a length scale parameter length scale that controls how quickly the kernel decays with distance. A larger length scale implies smoother variations in the function, while a smaller length scale allows for more rapid oscillations and localized patterns. 3. Period. The kernel has a period parameter period which dictates the length of the periodic cycle in the data. This parameter is essential for capturing the specific frequency of the repeating pattern. 4. Smoothness. The kernel exhibits smoothness due to the exponential decay function. This smoothness helps to prevent the model from overfitting to noisy data and ensures a stable and well-behaved prediction. 5. Stationary. The ExpSineSquared kernel is stationary, meaning that the correlation between 2 points only depends on their distance, not their absolute location. This property simplifies the computation and makes the model less sensitive to shifts in the data. Kernel function. The mathematical expression for the ExpSineSquared kernel is kx1, x2 exp2 simp abs x1 x2 period length scale 2. Explanation of the formula. x1, x2 the inputs for which the kernel is being evaluated. These can be scalar values or multidimensional vectors. Period. The period of the sinusoidal function, determining the length of the repeating cycle. Length scale. The length scale parameter, controlling the rate of decay and thus the smoothness of the kernel function. Simp abs x1 x2 period. The sine function introduces periodicity, ensuring the kernel has a periodic behavior. The absolute difference between the inputs x1 x2 is used to ensure symmetry and independence from the order of the inputs. exp2. The exponential function ensures a smooth decay in the kernel's value as the distance between inputs increases. YAML description. Let's analyze the key values in a YAML configuration for the ExpSineSquared kernel. YAML. Kernel. Type ExpSineSquared. Length scale 1.0. Period 10.0. Kernel. Type defines the type of kernel. In this case, it's ExpSineSquared. Kernel. Length scale. The length scale parameter of the kernel, set to 1.0. This value influences the smoothness of the function, impacting how quickly the kernel decays with distance between input points. Kernel. Period. The period of the cyclical pattern in the data, set to 10.0. This parameter determines the length of the repeating cycle captured by the kernel. Choosing the right parameters. Determining the optimal values for length scale and period is crucial for achieving good performance with the ExpSineSquared kernel. This can be done using grid search, exhaustively searching a range of values for these parameters to find the combination that yields the best model performance. Bayesian optimization, employing a more efficient approach by leveraging a probabilistic model to guide the search for optimal parameters. Visual inspection, observing the effect of different parameter values on the model's output and its alignment with the underlying data patterns. Applications. The ExpSineSquared kernel is particularly valuable in various applications, including Time series analysis, modeling time series data with periodic trends, such as seasonal patterns in sales or climate data. Signal processing, analyzing signals with cyclical components, like audio waveforms or sensor data. Machine learning, improving the performance of Gaussian process models for datasets exhibiting periodic structures. Key points to remember. Periodicity. This is the defining feature of the ExpSineSquared kernel, allowing it to capture recurring patterns in the data. Parameter tuning. Carefully choose the length, scale and period parameters to align the kernel with the specific characteristics of your data. Smoothness and stationarity. These inherent properties ensure stable predictions and make the kernel suitable for diverse applications. By understanding the nuances of the ExpSineSquared kernel and applying it judiciously, you can effectively model periodic data with Gaussian process regression in scikit-learn.